Hey everybody, this is Larry. This is the middle of the month, February 15th. The daily challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. I just woke up, so I'm a little bit out of it, but that's okay. Finally got enough sleep. Today's problem is the K weakest rows in a matrix. So I usually sub these live. If it's a little bit slow, fast forward or skip ahead to whatever you like, because I'd like to go over my thought process and not just give you the solution. Though I would also say that the last couple of problems have been a little bit on the easy side, so there's not much of that. But that aside, okay. So given an m by n matrix of ones and zeros, return the index of k weakest rows and weakest and strongest. What's weak? Okay, weakest. The number of soldiers in I, okay, or that the name of sub-soldiers, but I is less than J. What does I is less than J mean? Oh, the row, okay. Soldiers are always standing in the frontier of a row, so okay, so they are always in the beginning. Always ones appear first and then zeros. Okay, that's a really weird sorting problem, but that's not a big deal. And we want to do it from weakest, so that means the smallest number, right? So that's 2, 0, 3. Okay, so I mean this is just a sorting problem. So in different languages you can do use a comparator or whatever it is and then sort it and then return the index. So this is very language dependent, very library dependent. I don't know that this would be an interview question because this is too straightforward. This is literally a library question. Maybe they'll ask you to implement the sorting manually if you get a problem like this, but otherwise I think this is pretty straightforward. Okay, so the thing that I would like to do, and I'm a little bit yeah, okay, is yeah, okay, so for each I don't know that the frontier thing makes any difference. I mean, you can do it. You can make small optimizations based on this frontier thing, but I think it doesn't really matter. So I'm going to just so what I'm going to do now is just write it as I might write it on a competitive programming or something like that. But I'm going to try to explain it. So maybe I won't. Maybe I'll just write it out a little bit. But for now, we're going to convert. So we have an array of matrix. Oh, sorry, an array of arrays, which is a matrix, and then we convert these to the two things that we need for sorting, right? One is the number of ones, and then two is the index of the row. Okay, so now, so the index and then the row in enumerate matrix. Oops, cannot spell that. So this is how we do it in Python, and then row dot, I think count of, is it a number or is it a 0? Okay, yeah, 1. So let's go one count maybe, and then here we append it to an array that we can sort. So let's just say naming things are hard, so maybe take your time on that one. But what's it called? Strength maybe. Strength is equal to empty array. So we do string dot append one count index, and that's pretty much it really, because we do a sort afterwards, and then we just return the strength. Kind of, we want to return it without we just want to return the index. So we just do something like index for the count, index in strength, right? Convert it to a list just in case, and I think this is it. We'll go over it, don't worry. At least if this is right. If this is wrong, then maybe we would just cry a little bit. I'm just kidding, of course. Though I don't know. This is ooh. I might have to do some cleaning up this problems for input for testing. Okay, let's give it a run. Ow, I forgot about the K part, so I'm actually a little wrong. I actually did forget about the K part. So the K part in sorting, this would be there's a way to do it. You just get the first K elements, but you can do better. I just want to show that this is correct. Okay, but I forgot about the K part completely. So so it still happens, and of course during a competition, this is what I would do, and that would be good enough, right? So what is the complexity of this, and why would I not do it? Well, let me go over the solution real quick. Right, yeah. Let me go over the solution real quick, and this is not the optimal solution. Let me be clear. I just forgot about a K. But so this is not the optimal solution, but let me go over it just for learning purposes, and then we'll figure it out. So for here, we get the strength. We in Python we convert it to a tuple. You can also create an object that you sort, which is what you would do in many other languages, and that's probably the way that would be better in an interview, because that's more readable. I would mention that and then kind of go over it. And then sorting, what that does is that it takes the tuple and then do it one. It would do it index, or like, you know, it would sort by the first tuple component first, and then the second tuple component as a tiebreaker, and so forth. So in this case, it would sort by the number of ones, and then it would sort by index as a tiebreaker. And then we just get the index at the very end. This gets the index at the very end. This gets the entire list, and it is already sorted. And then this gets the last, or the first K elements. So what is the complexity of this, right? Well, is this a square matrix? No. Okay. But either way, yeah. So let's say n is equal to number of rows. M is equal to the number of elements per row. You know, this thing is going to be O of n times m, because that's just looking at each element once. It's a little bit obtuse, because this one row is essentially, you could treat this as a for loop for the row to count the number of ones. And then here is O of n log n, because you only have n elements. And then here you take, I mean, this is just linear. So the overall complexity is going to be O of n times m plus n log n. Time and space is just going to be O of m. Yeah. Oh no, the other one. O of n, sorry. Yeah, because strength is going to be n elements, and that's going to be linear time, right? Or it depends how you want to count linear, because the size of the input is actually n times m, so it's not linear, or sublinear if you want to call it that, for space, right? But you can do better. So how can you do better? So the first thing that you should do when you see anything about like top K or least K or most K or something like that, you should always think about a heap. I definitely should have thought about that, but then I totally forgot when I was looking at the rest of the problem. And during a contest, I would submit this, but for an interview, I would go back and I'll be like, oh, whoops. Maybe I should have read it more carefully. But yeah, and then I would use a heap. And why would you use a heap? Because then now, because you only care about the top K things, then, yeah, top K min things, right? So then you can reduce this from log n to log K, because you should be able to keep a heap of K elements, and that's it. And in this case, you'll use a max heap, because you want to get the K biggest item of the K smallest items. K. So you want to get the K. You want to get the max heap, because you want to keep track of the max items inside the smallest K items, right? And then just push them out, and that'll give you n log K. Yeah, let's do a quick one by that. It's a little bit messy in Python, because in Python heaps are min heaps. So to get max heap, you have to do a little bit of hacky code. There are other ways to do it, but that's the way I'm going to do it. So let's start again. Let's just go Shrink Heap, say, and then this is going to be the same. This is going to be the same, and then instead of appending it, we just check if length of Shrink Heap is equal to 0, or well, let's just yeah. If Shrink Heap is 0, 0, we push it to the heap. But instead of one count index, which we do, because we want to do this as a max heap, we're going to do the negative version of them, because negative version of a max number is a min number. It's a little bit hacky, as I said, but you know, we'll do this for now. And then otherwise, yeah, now we want to see if this number, check if one count index deserves to be in the heap. So then now, okay, let's delete these for a second. Now we check the top of the heap. So top one count, top index is equal to heap q dot strength heap of 0, kind of. Trying to figure about the negative 1 stuff is a little bit messy, but yeah, I like to convert them back to regular indexes so I don't get confused. Though it is a little bit yucky, like I said. Okay, so if let's see, if one count is less than top one count, or one count is equal to top one count. Actually, we could just do a tuple comparison, actually. So if one count index is less than top one count, top index, and this top is just the top of the heap, which means that this is the, because this is a max heap, this is the biggest element inside the heap, right? So what this means is that if this is the biggest element inside the heap, if our current number is smaller than it, then this deserves to be in the kth smallest one, right? So if this is smaller than that, we just push it to the heap. Again. And then at the very end, and actually I guess we should, maybe instead of out, we should do an else here. And the reason why is so that, and then now we can check, you know, to keep the size of the heap at most k, we do a check. If length of shrink heap is greater than k, then we want to pop it, right? So we actually, in theory, we can do this as a while loop, and sometimes I write it as a while loop, even though I know that this can only happen at most one item, but it's just a little bit easier. But it's also a little bit more inefficient, but it doesn't really matter. But yeah, oops, heap pop shrink heap. Because if this has more than k items, then we want to pop the biggest element so that we keep it inside k items. Okay, and then now we have, let's just have the results, and now we can pop everything back in order. Of course, as this is a max heap, we have to reverse the order afterwards, right? So yeah, so while length of string heap is greater than 0, results dot append. Well, let's get the, again, this code is a little bit yucky in Python. Or maybe we could just do, but you know, you do get a, but for interviews, this is what I would recommend, because if they ask a top k question, they probably want the heap version, to be honest. Yeah. So then now we just results dot append. Actually, we only care about the index, right? So let's actually convert this here so that we can make this part more readable. And then of course we have to reverse it, because now it is going in the reverse order, because it's max first. Okay, and let's give it some code again, some love again, and run it. Okay. Ooh, did I miss by k? Did I went off by 1 somewhere? Is it only? That's weird. Dun dun dun. Huh. That is odd, actually. Okay, let's print out Shrink Heap for a second. I probably just have a typo somewhere, but that's did not expect that. So there's 2 items inside the heap. Why is this? Like, this is the most dubious part, but why? Let's use some F string. Yeah, K is 0 to 3. Why do we not? Oh, I am. That was just a coincidence. I'm being silly. So. Okay, so this is that, or it is less than K. Yeah, because if you have fewer than K items, you don't have to do this check. I am, well, clearly a little bit rusty. So yeah, this is even the. Actually, I guess we don't even need to. I mean, I guess this is actually a little bit confusing now that I think about it. I mean, I think this will work if I do it this way. Yeah, but I think we can actually clean it up a little bit. Yeah, just to be clear, this is correct. But I think we can clear this up. I think the way that I did this is, maybe I am a little bit rusty, because I actually don't think now I think with the invariants, you can actually remove all this. And we could just do this. And the code is much cleaner. And this is what happens, I would also say, about practice, right? Is that without practice or whatever, you know, you will still get, you're still able to come up with the results, and that's probably good enough a lot for an interview, to be honest. Like, it's not a big deal. But you know, the time you spend in practice, like I do here a little bit, you'll see that I can clean up the code a little bit in a way that I'm like, oh yeah, that's right, this, you know. So then I could clean up all that code, and now this is actually much tighter, right? Okay. And the reason why this works is, we'll go over it in a second. Okay, let's give it 1.1 code, just in case I change something by accident. Okay, let's give it a submit. Cool. Yeah, so now what is the complexity, right? Well, this is still, you know, let's erase this for a second. So this is O of M, because for each row there's going to be thing items. This is going to be O of N iterations, but here we have a heap push, which is O of log K, and the pop, which is also O of log K. So this for loop, these for loops will combine to be O of N times M plus N log K. Right? I hope this makes sense. This is a heap, so, and this is log K because the heap will at most have only K elements, or K plus 1 element for a second, as kind of the loop invariant, right? So that's the time. And here, of course, it is just K log K, so because the heap will have K items and we do K pops, so this will have at most K log K, which of course gets dominated by this other part, so this is still the running time. And this is O of K times, I guess. And in terms of space, of course, we only use it for the heap and the results. The heap will have K items, the results will also have K items, so this will be O of K space. So as you can tell, if you go back, if you rewind a second, this is clearly much, you know, this is more efficient in time and space. So yeah, cool. And yeah, this is the heap-based solution. This is a max heap, and yeah, and this only happens after K items, and that means that the heap will have at most K plus 1 items. So yeah, still log K. And that's the loop invariant that we call, because if once it goes over K, we always pop this the biggest element from the top K smallest element list. So yeah, that's all I have for this problem, I think. Let me know what you think, and yeah, let me know what you think. Should be okay. Let me take a look at the hints, see if there's anything I missed. Okay, but that's not the log K version. Okay, fine. But yeah, this is the log K version, and obviously in your language, there could be, in your language there, it doesn't have to be heap. It could be in anything. So I mean, it'll be heaps in your language. But yeah, okay, that's all I have. Happy President's Day if you celebrate it, or just taking the day off. Happy belated Valentine's Day and New Year. And I will see y'all tomorrow. But after me saying, to good mental health. Bye bye.